So hello everyone, these are the great network questions. So in this question we have to find out the z parameter. Z parameter. Okay. Uh, we have to find out the z parameters. For z parameter, z equals to v upon I. So if we say v is equals to zi. So in this z, v is the dependent parameter and I is the independent parameter. So what equation we have to form is v1 is equals to v1 is equals to z1 I1 plus z2 I2 and v2 is equals to z1 I1 sorry z11 z12 z21 and I1 plus z22 I2. So we have to find out this z11 z12 z21 and z22 parameters. So for this we let's denote the current here. So this is I1 and let's suppose I current flows there. So I minus I1 current flows. Okay, let's note the other way. This is at this node I1 current is flowing and I say I will note that this current is I and this current is I1 minus I and what current is here, then there is I1 minus I and I2 is there, so current will add up and we will get I1 plus I2 minus I1 and negative current will flow, negative I1 flows here and negative I2 flows here, so it's not negative only I1 but in this direction only I2 in this direction. Okay, so I1 flows there, I1 flows there, what current is flows there, I2 minus I1 or my, we can say I1 or not I1 or only we can say uh, I minus I2. So now write the KVL equation for V1 and V2. For KVL equation for V1 node at V1 we will note it as V1 node at V1. So first see this path. In this path, uh, this this is the V1 voltage, which is V1 is equals to I. V1 is equals to V1 is equals to this is I and this current is I minus I2, so I minus I2 6 ohm. This is V1 when we follow this path, and when we follow this path, okay, when we follow this path, that V1 is I1 minus I, which is 3 ohm. Okay, so if we calculate it, it will 6I minus I2, 6I2, and this is 6I1 minus or not 6I1, this is 3I1 minus 3I, and this is equation first and equation second. If we solve it, we will get V1 is equals to V1 is equals to 2I1 minus 2I2. Now this is our point of interest equation, like we will denote this as 3. Now, now apply KVL at V2 node. If we see V2 node, follow this path. If we follow this path, we will get uh, V2 is equals to 6I2 minus I1, as this current is I2 minus I1, current is I2 minus I1, and if we follow this path, then we will get V2 is equals to 3I minus I1, 3I minus I1. Now if we solve this equation, we will get V2s of 3 V2s 3i1 th no, we'll get V2 as minus 2i1 plus 2i2. This is simple elimination method. You can solve by yourself. Then we will get our second equation, which is denoted as equation fourth. Now solve this equation. No, not solve it. That we will get V1, which is 2i1 minus 2i2, and V2, which is minus 2i1 plus 2i2. So our matrix is Z matrix is 2 minus 2 minus 2 plus 2. So this is our final answer. Now move to the second question. In second question, okay. In second question, this question was given in when t less than 0 time period. This circuit is in equivalent and in steady state, and at t is equals to 0. This switch is moved from position 1 to position 2, and we have to find out the voltage equation of capacitor. So this one is very simple. So first we will analyze by for t less than 0 part when the circuit is in steady state. In steady state, as it is in this circuit is for the switch one at position 1 is for a very long time, so we can assume that this circuit is in steady state. At steady state, capacitor will open, cap behave as an open circuit. So if we see, so this circuit will become like this. It's 3 ohm, 2 ohm, and 10 voltage source, 10 volt voltage source, and this is capacitor. We can denote this as open circuit. So it is a simple voltage area circuit. So and we can find out the voltage equation, voltage on a capacitor when we see 0 minus at a 0 minus, which is a simple voltage divider circuit. 2 in 2 into 5, 2 divided by 5 into 10, and we can get that t less than 0 voltage on capacitor is when t is less than 0 is 4 volt, and it is applicable when t greater than 0, means when at t greater than 0, at a 0 plus, it voltage would not change, as uh, there is no impulse current will flow from here to here, as there is some resistance connected between capacitor and this current source. So no sudden change occurs in the capacitor. So at a 0 minus and 0 plus, the voltage is same. So now move to the second part. When t greater than 0, at t greater than 0, now the in this circuit a capacitor is here at resistance, and there is a current source flowing here, and we have to find out the t greater than 0 part. So for capacitor voltage, there is one equation we can derive this also, but for the timing you can remember this equation, that voltage on capacitor is v final plus v final plus v initial minus v final, I'm denoted as va, into t by tau. T is time and tau is the time period of the circuit, and for the time period of the circuit, we can calculate the time period. For the time period, we have to time period for this circuit, for the time period we have to of the independent sources, of all the independent sources. So this one is the independent source, so we have to cancel this out of, we have to of this circuit. So it will look like this. This is a capacitor, and this is another resistance, and if we off the current source, then it will behave as an open circuit. And for the open circuit, for the open circuit, now uh, the tau is R equivalent and C equivalent. So if we can see that this resistor, one node is connected here and one node is a free node, so we would have to consider this node in our time tau in current equation. So R equivalent is these two resistors are in series, so these two resistors will add up, which is 6 ohm, and the uh, capacitor is 0.1 farad. So capacitor is 0.1 farad. So if we solve this, we will get 0.6 second. So the time constant is 0.6 second, and then now uh, V final is when this circuit achieve V final when it is in steady state at t is when t reaches to infinite circuit reaches steady state. At steady state capacitor will open. Okay, so this circuit will behave like this. Like capacitor is open, this resistor is here, this is here, this is here. So this resistor is 2 ohm, this resistor is 2 ohm, and this one is also 2 ohm, and a current of 5 ampere will flow like this. This is current source, 5 ampere current source flow in this path, and we have to find out this voltage, as this voltage will appear on the capacitor. So what is this voltage? This is 5 ampere, and uh, so V final uh, V final will become 5 into 2, which is 10 volt. So this 10 volt voltage appears on this resistor. Now we can put all this value on the equation, and we will get VCT is V final. Sorry, now we have to put the values. So V final is 10 plus V initial is 4 volt minus 10 volt E minus T by tau. Tau is 0.1 seconds. So if we will get if we solve, we will get 10 minus 6 E minus 10 T. Oh, 0, not 0.1, 0.6. So 10 T upon 0.6. This is the voltage equation of the capacitor. This is our final answer. So we can see this one is correct. Now we can see that there is 4. 4 is not a final value. There is also 4. 4 is not a final value, and there is time, but there is no 6. But there is no in this difference of the final and initial will not be considered. So the final answer is B, and we can see this by waveform. We will put the waveform, like if this is an interview question, you can solve like this. This is a time axis, and when t less than 0 time, this is VCT 0, VCT capacitor voltage, and this is time axis 0. When for t less than 0, capacitor voltage is 4 volt, and it is a kind of step voltage. And uh, when uh, when t greater than 0, at t is equal to 0 minus is 4 volt, and t is equal to 0 plus is as well 4 volt. But when t greater than 0, it will achieve a steady state of 10 volt. So this is a 10 volt, 10 volt, and it will reach here like this, and with the time constant is 0.6 second. So this is the graph for the circuit.